Welcome to the Blade Lab. So this video is going to be a disassembly of the Kunwu Gringo. I'm also going to replace the stock bearings with multi-row Skiff bearings. I'm going to remove the blade and test it for hardness, and then I'm going to reassemble. Parts of this will be sped up for your entertainment. So this is a removing the pivot screw, which is a T8. Fortunately, all of the hardware is T8. The Timascus pivot collar also came off in this instance. I'm going to take out the other T8 body screw. As you'll see, the pocket clip is actually secured with a screw. Well, in this case, two screws, because I have the milled pocket clip installed. Oh, no, wait, sorry. It's just one screw. But that also is a structural screw. It holds the scales together, so that has to come out as well. The screws, all of them were tight. I don't think that they were Loctited, so didn't require a sort of Herculean effort to get them out. Just a bunch of wrist turns. So this is a bit of a longer one, so here I need to give it a few more twists. Now, so obviously the clip comes off. You can see that it's sort of a wire clip type of attachment, and in fact the knife comes with a wire clip, which I'm also going to put on at the reassembly stage. The reason for that, I'll discuss it at more length in the review, but I just found it a little bit too tight for the sort of thick seamed shorts that I usually wear. So now I'm just using this sort of plastic spudgy thing to pry it apart. It's a little bit tight tolerances, which is not a bad thing. And now you can see that you can see the multi-row bearings. And just showing an internal shot. If we can get some focus here, focus. So nice weight relief. You can see the lock bar insert, which also serves as the over travel stop. And steel washers to run against the ceramic bearings. All good stuff. Now let's pop the blade out and take the bearings off. You can see all the lube that you see in this was on the knife as received from Kunwu direct. So I think that's I guess it's nice that it's lubricated, but I find that they kind of overdo it from the factory, which makes the action a little bit sluggish. So even though I'm replacing the bearings, I'm not necessarily sure if that was necessary, or if I probably could have just cleaned it all up and put some a little less lube and probably a better quality lube in there, and the action probably would have been perfectly fine. But since I happen to have a set of Skiff bearings that fit this knife, I figure I might as well put them in. The factory bearings are often quite adequate, but I believe Skiffs are the best that are available. So if you have them, why not put them in? If you don't have them, probably don't need to buy them. Okay, so now that we've taken the blade apart, I'm going to use a Lieb hardness tester to see what the HRC is of this particular blade. It is S390 steel, which I talk about in the review, looking like it's really good stuff, as it should be from the chemistry. Kunwu lists the HRC range for this at I believe it's 65 to 67 HRC. So I am expecting this particular example to come in that range. Kunwu is they're almost kind of like the Spyderco of the new knife companies, in the sense that they are kind of into heat treating and also into trying out different, more exotic steels than a lot of other Chinese-made knives are using. So the way this hardness tester works, I've got a separate video of that, but it's like a rebound tester. That little pen device has a sort of projectile that you cock it and shoot it at the a flat part of the blade. It rebounds, and the height of the rebound indicates the hardness of the blade. Usually these are used in industry, kind of on a portable basis for testing, pipes and other fittings that are hard to move, that you couldn't really put under a standard dimple type tester. I'm finding it to be quite accurate though when it's calibrated to use thinner materials. However, you still have to sort of affix it to a thicker piece of steel, and that's what I'm doing here. I'm putting it on this heavy metal pedestal. I've got some petroleum jelly to fill any pockets in case the tang isn't completely flat. The key to this, to accuracy with the lead tester, is to have a solid bond between the blade and the pedestal, and that depends in part on how flat the tang itself is, and I can usually tell from the sound of the impact. And maybe what I will do, well, no, I won't. I'll just run these tests. I'm going to test it 3 times, and then the little machine will average the 3 readings together to give me a final result. So we got a 65.9, 66.4, and a 66.3. So that averages out to 66.3, which is just slightly in the high range of what they estimate. You can see the small little dimples that it leaves in the blade here, much smaller than your typical Rockwell tester, but not non-existent either. Now this is a DLC coated blade. As a rule, they tell you that you should strip the coatings off of blades to test the hardness. I have done that with a few knives, and I'm not really finding much difference between coated and non-coated with the lead tester. So real happy with those hardness results, and now we're on to the bearing switch. So I'm using this card that Skiff offers, and you can use it to measure the radius or the diameter of the pivot. Excuse me. Which which in this case was 6 millimeter. The bearing size is 1/16 inch. So there is the package. And now I'm just going to speed this whole thing up because it's just not that interesting. Didn't really have any problems doing any of this. Putting on some nano oil. I like to lube everything, but not to excess. What I'll usually do is put sort of 1 or 2 small drops on the washer, on the blade, the recess in this case where the bearing fits in, and on the detent ball and on the detent ball track. And that is what I'm doing here. So this comes back together quite easily. Now I'm just putting the screws back in and also installing the wire clip, which installs with 1 screw. Here I kind of screwed up and didn't put the screw on before I mounted the clip. So now we're just going to tension everything up a little bit, I guess this will be sort of the semi-final tightening. Gotta make sure the body screws are fully tightened. Notice I'm not putting any Loctite on. I usually don't unless I have a particular reason to. Something comes loose. I find if you just tighten the body screws down, they generally don't fall out. Pivot screws, I prefer not to muck it up if I don't have to. So I will start out without using Loctite, and then if it starts to back out over time, then I'll just go back in and Loctite it. So here we have a pretty good result. There was no blade play, but I'm just going to tighten it up a little bit more and see how that affects the action. Still drop shut. And it's all good. There is no blade play. It's drop shut, but not sort of frightening drop shut. The blade is perfectly centered. And that, my friends, should about do it. Give it a few other looks. So if you haven't checked out the review, I will post that probably before I'm posting this. And check it out. It's a very cool knife. Really unusual steel for the knife industry. And in my early experience, it's looking like a really good performer. So thanks for stopping by, and y'all have a good one.